Well, you've done angles and measured angles and worked with that. We're going to go a little bit further with our geometry. Today we're going to look at perimeters and areas. And of course, depending on what your figure is, we can find perimeters and areas a little bit differently. First of all, with perimeter, perimeter is the distance around an object. With a triangle, if you have a triangle and you don't know anything else about the triangle, then we assume that it probably has 3 different lengths of sides. So to find the perimeter, the distance around, we simply add the measurements of the 3 sides together. You can do that with any figure. If you know all the sides, you add them all up. Sometimes we won't know all the sides. So with a rectangle, one thing we do know about a rectangle is that it has 2 pairs of equal sides. Those sides would be equal and those sides would be equal. So in the past, you may have learned length and width just to keep things consistent. We're going to look at this as base and height. So to find the perimeter, you know, if that's B, this is B. If that's H, this is also H. So we would take 2 times the base, because there's 2 of them, plus another way to write that, and it's up to you which formula you want to remember. It would be 2 times the base plus the height. Sometimes I prefer to use the second one because you just add the base and height together and then multiply that sum by 2. To use the first one, you multiply each of them by 2 and then you add them together. That's how you find the perimeter of a triangle and a rectangle. I'm going to try to fit a little bit more on here. And that is, what if we have a square? Well, a square is a rectangle. However, what we do know about a square is that it has 4 equal sides. So we often will label it S for side. To find the perimeter of the square, since all the sides are equal, it's just 4 times S. The reason why this is helpful rather than the previous that we used for rectangle is because often they'll only tell us one side of a square. They'll say, find the perimeter of a square that has a side of 2. Well, if the side's 2, you multiply that times 4, and you end up with 8. One thing that I have not mentioned is the units that we use. For perimeter, the units are the same as the units that you were given. If this was in inches, the perimeter would be given in inches. If it's centimeters, then the perimeter is in centimeters. We call it a linear measurement because all we're doing is measuring lengths. The next thing that we need to look at is area. Area is always given in units squared. Okay, what you're really looking for with area, no matter what your shape is, you are filling it up with squares. And sometimes you might have something that's not quite a square, but it's part of a square. So you figure out how many squares it will take to fill up the figure. So that's why it's in square units. And that's what we're looking for when we find area. The area of a triangle is 1/2 the base times the height. Where does that come from when we were using A, B, and C for the sides? Well, the base can be any side of the triangle. If this is the base of my triangle, the height is drawn from the opposite vertex. Okay, this is opposite, it's not part of that side. And it is a segment that is drawn so that it is perpendicular or forms a 90-degree angle with the base. If I had a triangle that looked like this, and this was my base, I need to find a segment that goes from this vertex and is perpendicular to that side. Well, in order to do that, I need to extend this side and draw a segment that's perpendicular to it. So if you have an obtuse triangle, that's a triangle that has one obtuse angle in it, then the altitude, the height, may be drawn on the outside of the triangle. Another special situation that we sometimes have with triangles is, what if we have a right triangle? If this is a right triangle and that is a right angle, then I know if this is going to be my base, the height has to be drawn from this vertex and it has to be perpendicular to the base. Well, that side, which I didn't follow very well, that side is perpendicular to the base. So with a right triangle, the two sides that form the right angle are your base and your height. So that is how we find the area of any triangle. It's going to be 1/2 the base times the height. You just have to make sure that no matter what kind of triangle you have, the height has to be a segment from the opposite vertex and perpendicular, or forming a 90-degree angle with the base. With a rectangle, finding the area shouldn't be too difficult. If you look at this diagram I have here, if we draw squares inside of that, if each square is one unit by 1 unit, there are going to be B of them across the base. If B is 6, there's going to be 6 of them that fit across the base. But if H represents how many units there are in the height, we're going to have that many rows of them going across. So to find the area of a rectangle, you simply multiply the base times the height. Whatever the base is times the height. Another thing that's important here is to remember that in a rectangle, the base and height are perpendicular to each other. So similar to a triangle, we do have perpendicular sides when we're finding the area of a rectangle. And whatever the units are, its units squared would be the units that you use for a rectangle. The next thing I want to look at is a square. I'm just going to put that here. For a square, remember with a square, all of the sides are S. So if we multiply the base times the height, we end up with the area of a square simply being the side squared. As I said when we were looking at perimeter, often they'll only give you one side. Find the area of a square that has a side of 7. Well, all you have to do is square 7. 7 squared is 49. So it'd be 49 square units, whatever the units are. So I've gone over the perimeter and area of triangles, rectangles, and squares. There are a couple other figures that we're going to look at. And one of them is a parallelogram. A parallelogram has 2 pair of parallel sides. And similar to a rectangle, those parallel sides are equal to each other. If I start at that vertex and I draw a perpendicular, think of cutting that triangle off. If I remember, this side was parallel to this side. So if I pick this up and put it over here, those sides are going to match up exactly because they were parallel. And that part that I took off of here is going to fit here. And it's going to fit in there just like that. This length at the top hasn't changed at all. And because I have a perpendicular there and a perpendicular there, that's going to be the same as that. I have a rectangle. This is the base and this is the height. So the area is base times height. However, if you look at the original parallelogram, was drawn right there. The height was not a side of the parallelogram. Just like with many triangles, the height is drawn perpendicular to a side. So if I had another parallelogram over here, I need to know this height and the base, and then I can find the area. It doesn't matter really what this side is. You just need the height and the base. And at this point, you'll be given enough information if you need to use that formula. The other figure that we're going to look at is a trapezoid. Don't get the trapezoid confused with a parallelogram. A trapezoid has only one pair of parallel sides. The other sides are not parallel. Okay, if this is your trapezoid, this base and this base, the base are the parallel sides, they're not equal. Since they're not equal, I'm going to call this base 1 and this base 2. Be careful how you write those. Those are supposed to be subscripts. That way you won't get confused that it's a multiplication or an exponent or something. You also, in this diagram, need to know what the height is. The height is any segment that goes from one base to the other and is perpendicular to both. The area of a trapezoid is 1/2 base 1 plus base 2 times h. You may have seen this written as b1 plus b2 times h all over 2. It's the same formula. It doesn't matter how you write it. You have to add the two bases together, divided by 2, and then multiply by the height. Or you can add them together, multiply by the height, and then divide the whole thing by 2. That's how you find the area of a parallelogram and a trapezoid. That finishes our lesson with giving the formulas for trapezoids. And that sums up our lesson on finding perimeters and areas of different figures. There will be also a video for examples, and that will follow this one. It doesn't matter how you write it. You have to add the two bases together, divided by 2, and then multiply by the height. Or you can add them together, multiply by the height, and then divide the whole thing by 2. That's how you find the area of a parallelogram and a trapezoid. And that sums up our lesson on finding perimeters and areas of different figures. There will be also a video for examples, and that will follow this one.